Three.
Good morning. Today, I would like to talk about climate change in terms of 9 topics: fossil fuels, renewable energy, cyclones, hypocrisy, governance, CO2 coalition, model, lessons learned, and a roadmap. I have prepared this talk for students with 3 things in mind. 1, atmospheric sciences. 2, empirical data. 3, common sense. As you can see, I received my master's degree from this department in 1972. That is exactly 50 years ago, under the supervision of Professor Stanley Fisher. To show my gratitude, I have established an endowment in his name worth $50,000. I will pay $25,000. ExxonMobil will match $25,000. The idea is to fund research in geological sciences by the faculty and student under his name. To give you some background in terms of history, how I got involved in this climate change domain, it started in 1988. The same year, IPCC was started. IPCC stands for Intergovernmental Panel on Climate Change. In 1988, Professor George DeVries Klein was the editor-in-chief of the Earth Science Reviews. I submitted a paper on submarine fans with my co-author, Richard Maiola. He liked the paper and he published it, and he sent me a glowing commentary on that paper. Ever since we became friends, he kept me informed on climate change. He would send me articles, emails, and so on and so forth. He passed away in 2018, and I was in the editorial board of this journal of the Indian Association of Sedimentologists. The managing editor, Professor Ghulam Bhatt, was very enthusiastic in dedicating a special issue for George Klein. We did. We invited people like Dr. Van der Lingen from New Zealand to write an article on climate change, and he did. The title is called Postmodernism and Climate Change, and so on. After that, more recently, last year, Alex Epstein published a book called Fossil Future. The purpose of this book is to show that fossil fuels are not bad. The current environment, the people emphasize the negative aspect of fossil fuels and kind of ignore the positive aspect of fossil fuels. I like that, so I wrote a book review on this book. It was published on this journal. The image you see here is actually from my book review showing the atmospheric sciences of this domain. Then this year, Professor Ghulam Bhatt was appointed as the editor-in-chief of this Journal of the Geological Society of India. He invited me to contribute an editorial on a topic of my choosing. I chose climate change. That will be published in July or August. The other reason I'm interested in climate change, because I'm a petroleum geologist. After 1978, I received my PhD. The same year, I joined Mobile Research in Dallas. This is the first research center I joined. And at that time, Mobil was the second largest company, oil company in the world. They wanted to expand research. So they hired I.M. Pei, one of the world-renowned architects. He was the one who designed the Louvre Pyramid in Paris, and the Bank of China building in Hong Kong. And he designed this research center for mobile. That's where I worked from 83 to 92. Then I moved to this research center from 92 to 2000. I retired in 2000. The same year, Mobil merged with Exxon, and it became Exxon Mobil, that is today. And after that, I became a consultant. In this topic, I would like to define certain terms. First is the weather. It represents state of atmosphere at a local level over a short period of time, say in a day. Whereas the climate is the average of the weather pattern in a regional or global level over a longer period, say 30 years. I also like to go through some of these acronyms. I already mentioned IPCC, Intergovernmental Panel on Climate Change. As we encounter more terms, I'll explain to them. The next topic is fossil fuels. I would like to talk about the world GDP per capita. There is a paper by Darwall. I show this paper from him, published in 2020. This is the diagram he published. He looked at 2,000 years of GDP. Let's go back in time. 2,000 years ago, the GDP was just a few $100s, and it remained that way for a long time until we hit here, and it just takes off to $6,500. And why? Because of the Industrial Revolution. Let's look at some of the things happen here. In 1764, James Watt invented steam engine in Scotland. In 1870, John D. Rockefeller started the Standard Oil Company in Cleveland, Ohio, that has become ExxonMobil today. In 1903, the Wright brothers in Dayton, Ohio, they invented aircraft. And during the Second World War, the jet fuel were the key factor in winning the war, because the Allied nations, such as US, USSR, and the related nation, Venezuela, they all had large deposits of oil. Germany did not. So we should be thankful to fossil fuels for the freedom we are enjoying today. Let's look at the importance of oil in everyday life. If you take a barrel of US oil, it is converted into 46% gasoline that you put in your car, 9% jet fuel, you use it in your plane, 26% diesel that you put in the trucks that delivers your Amazon products every day. So without oil, there is no modern living. Let's compare fossil fuels with renewable energy. Fossil fuels are oil, natural gas, and coal. Renewables are solar and wind. We use 80% of the world energy from fossil fuels, only 3% from the renewables. We use in agriculture, fertilizer, heavy machinery, aviation, we use fossil fuels. We don't use renewable. We have over 6,000 products, petroleum products, from fossil fuels. We have zero. In fact, if you look closely, each one of you is wearing one of the petroleum products, either in the form of a shoe or a belt or a lipstick and so on. In terms of worth, it's cheap, reliable, and is expensive and unreliable. Let's look at the global poverty. In spite of all the advances we have made during the past, there are 800 million people, that is 10% of the world population, has no access to electricity today. So our immediate goal should be to lift these people out of poverty and bring them some kind of normalcy in their life. The next topic is the tropical cyclones. There is this view that tropical cyclones are caused by anthropogenic global warming. The idea here is people use fossil fuels that generate CO2, that increase ocean temperature, and that cause cyclones. That's the idea. Let's look at the data. This is an image of the planet Saturn, and they have recognized cyclones on planet Saturn. As far as we know, there are no human beings on Saturn. There are cyclones on Earth, and there are people on Earth. This is Hurricane Floyd, Category 4, that is 210 to 249 kilometers per hour wind velocity in Saffir-Simpson scale. These are very powerful agents. When Hurricane Floyd, before it hit, the Atlantic shelf was calm. You can see the rivers bringing in sediments. When it hit, the entire shelf was stirred up because it was so powerful, and it was shedding sediment into the ocean. This is all published in great detail in a paper I published in 2008 in the AAPG bulletin. And these storms, they destroy major oil platforms in the Gulf of Mexico. So we should know why they form, how they form, where they form, and so on. There are at least 7 factors. They have to come together in order to trigger a cyclone. Usually they form in adjacent to the equator, where the temperature is 80 to 90 degrees Fahrenheit. And they also need moist layer, low wind shear, disturbance, and so on. Let's look at the Atlantic hurricanes. They all form in a small island called Cape Verde. That's the red dot. And it generates, comes and hits North America. Let's look at the population here. It's about 500,000 people. In terms of CO2 emission, this is ranked 177th in the world, one of the last countries in terms of carbon emission. If that's the case, why all these hurricanes are generated here? One thing is for sure, it is not because of the high population in this island. Let's go to a country called India. It is the second largest densely populated country in the world. On this side, in the Bay of Bengal, we have 9 cyclones per year. So they call it the storm surge capital of the world. And if you go to the Arabian Sea, there are only 2 cyclones per year. Sometimes there are no cyclones in some years. So if the human beings cause cyclones, why they generate so much on this side, nothing on this side? The point is, human beings have nothing to do with cyclones. There's a paper published recently that looked at the frequency of cyclones from 1900 to 2020. It goes down gradually. If the people are causing cyclones, the trend should be the other way around because population increase. So the conclusion here is human beings have nothing to do with cyclones. They can neither create nor stop cyclones. Let's go to the next topic, hypocrisy. I'd like to use Germany, for example. because they were considered in 2021 the number one in using renewable energy. They were also getting cheap gas from Russia through these two pipelines called Nord Stream 1 and Nord Stream 2. And last year, Russia invaded Ukraine. As a result, the Western countries put sanctions on Russia. So they stopped selling gas to Germany. In the middle of all this, someone blew up these two pipelines, that causing damage. This is a photograph of the methane emission from the damage. So because of all this, Germany suffered a major energy crisis. This is actually a Reuters headline. The energy crisis fuels coal comeback in Germany. So they dropped renewable energy, went back to coal. Similarly, other countries like Great Britain, France, Austria, they all went back to coal because of the energy crisis. It's going on right now. But in 2021, there was a climate conference called COP26 in Glasgow, Scotland. At that conference, all these countries criticized India for using coal. But the following year, they all went back to coal themselves. So the point is, there is a hypocrisy of Western countries. Then the World Meteorological Organization published this diagram, and it showed the methane emission goes up from 2004 to 2021. During these 17 years, the emission of methane went up 20 parts per billion. That is 1.17 parts per billion a year. It's a very minute, trivial amount. But the media made a big deal about it. At the same time, last year, when the Nord Stream pipelines were blown up, during 6 days period, it emitted 220,000 tons of methane into the Baltic Sea, the biggest man-made natural disaster in human history. And the media said, no big deal, we'll move on to the next story. That's the media hypocrisy. Let's look at the top 10 countries in the world that emits 62% of the CO2 into the atmosphere. China is number 1. Germany is number 8. Let's plot this on this diagram, on this image. China here, Germany here. Even if Germany emits 0%, it doesn't mean anything for global warming because the atmosphere is an open system. There is no wall that separates China from Germany. So the Paris Agreement that tries to get all the countries to stop emitting CO2, it won't be effective until all countries signed on to this agreement and they all stopped emitting CO2. That will never happen. Let's go to the real cause of the climate change. What we're really talking about is temperature increase. If you want to find out what really increases the temperature, number 1, sun's radiation. Number 2, Earth's atmosphere. Number 3, greenhouse gases. There are many of them: H2O, methane, CO2, N2O, and O3. And finally, yes, there are fossil fuels. But the media and the politicians, they got onto this fossil fuel and CO2. They pretty much ignore the most important part of it. So let's say we have the power to get rid of CO2 completely. Say we have the magical power, and we can write a law in Washington, D.C. to get rid of CO2 zero. You do that, we even get rid of the atmosphere. You know what will happen? It will decrease the temperature to minus 18 degrees centigrade. We'll be freeze to death. So be thankful to CO2. Because of CO2, you are alive today. Let's look at the other points. In terms of understanding temperature on Earth, let's use some common sense. This is sun with temperature 5,600 degrees centigrade. If a planet is located closer to sun, it is warmer. If a planet is located farther from the sun, it is less warm. Let's look at the temperature in Mercury, 167 degrees centigrade. Let's look at Earth, 15 degrees centigrade. Of course, there are other factors, but sun is the primary factor. And there are people, global elites, they take their private jets, fly to Davos, Switzerland, to attend the World Economic Forum every year. It happened this year. This picture was taken this year. So they emit a lot of CO2 by flying these jets. And once they reach Davos, they talk about how to stop emitting CO2, how they can control the poor countries, and how they can minimize CO2 emissions and so on. So this is the ultimate in climate hypocrisy. And of course, we use wind turbines, solar panels. They're all to collect renewable energy. And they're all made of petroleum products. And we want to use electric cars. Each electric car has 772 pounds of petrochemical plastics. And they use lithium and cobalt for the batteries. They mine these in countries like Congo using child labor. And when you look at the wind turbines, they kill birds. Just keep this image when I talk about the next image. This is a live whale. Until 1860, we used to kill whales for their whale oil, for using in illumination lamps and so on, machine lubrication. In 1860, when petroleum became abundant, we stopped killing whales because it's much cheaper and cleaner. So compare that with the previous image. The wind turbines kill birds, petroleum saves whales. And to protest against this climate change and so on, people go to the Louvre Museum and they threw pie and cream on the paintings of Mona Lisa. This is one of the greatest paintings of all times, and they were trying to destroy this painting. And they go to Royal Academy of Arts in London. The students, they glued themselves to the painting to protest against oil. We use oil, they don't like that. So let's look at the logic here. The glue they used is a polymer that comes from oil. It is a matter of chemistry. So these students, I don't know how much chemistry they had. So they had to know the glue comes from oil against which they are protesting. Let's go to the net zero ultimatum. President Biden proposed by the year 2050, we'll have net zero CO2 emission. If it is implemented, the only way we can accomplish this goal is to eliminate fossil fuel completely. Otherwise, it cannot be accomplished. So most of you students today, you are all young, you will live through the year 2050. Let me give you a sample of how it might look like if we go through this net zero policy. I selected 9 examples. You'll get up in the morning, you want to go to the toilet. There won't be a toilet because it's made of petroleum products. Most of students, they brush their teeth, they need toothpaste and toothbrush. There won't be anything like that because they're all made of petroleum products. Some of the students, they jog in the morning. They won't be able to use the jogging shoes. They are petroleum products. So they have to jog barefoot in the park. You can't drive, you can't fly, you can't go on your cruise, you can't play video games, you can't wear masks in the hospital. At the end of the day, you want to go to sleep. You can't use these nice polyester pillows. They are all petroleum products. So what do you do? There is still one option left. You can go back to the caves, live like Neanderthals who lived 40,000 years ago. They didn't have toothbrush, they didn't have shoes, they didn't have cars or planes or phones. So this is what you are looking at if you implement the net zero policy. Let's go to the next topic. This is ESG, environmental social governance. In 2021, the government abolished the use of chemical fertilizer to save the planet. As a result, they reduced crop yields. They went into shortage of fuel, food, money. The government declared bankruptcy last year. So there was a large protest. The interesting thing here is Sri Lanka is composed of 70% Buddhist. This is one of the passive religions on earth. And they're all protesting against the policy of the ESG. This is what happens when you try to save the planet using governance. And let's go to Netherlands. The government wanted to eliminate 30% of the livestock because they emit nitrogen through their manure. And the farmers in that country formed a party called BBB. They didn't like this policy. They ran against the policy in the election. It was exactly 1 month ago, on March 15th, and they won a major victory. Now they have a problem between the government and the Farmers' Party. The next topic is CO2 Coalition. It is a nonprofit organization. It's headquartered in Arlington, Virginia. It started in 2015. The purpose is to provide facts, resources, and information about the vital role of CO2 plays in our environment. There are about 140 members right now. They're composed of scientists, engineers, medical experts. I joined this group recently. The executive director is Greg Wrightstone. Our goal that CO2 is essential for life, that is both for plants and for people. From that group, two scientists, Happer and Linson, published a report last year. To give you some background about these two authors, Happer is a professor emeritus of physics at Princeton University. Richard Linson is a professor emeritus of atmospheric sciences at MIT. So they calculated the temperature of the Earth in the future using Planck's curve. What is a Planck's curve? It is this curve as opposed to this curve. This is the classical physics Rayleigh-Jeans curve. And here, the energy comes continuously. It goes into infinity. They don't explain the ultraviolet regions and so on. Whereas the Planck's curve, they do. In this curve, the energy comes in discrete packages or quantized. That's the origin of quantum mechanics. So the curve goes up. This is the peak wavelength, and it falls off. So Happer and Linson used this curve. This is that blue curve, is that Planck's curve. What they did was they want to know What will happen to the temperature if we simply double up the CO2 from today? Today, it's about 420 parts per million. And if we increase to 800, what will happen? Intuitively, you would think it's going to increase the temperature tremendously. But they found out the temperature increase will be trivial. It'll be less than 1 degree centigrade. That's because the atmosphere, once you start pumping CO2, the temperature is not going to be greatly increasing because it's saturated CO2. It's going to be minimal and the temperature will be level off. So this part of the story is seldom told to the public. We always think of when you put CO2 into the atmosphere, there's going to be a temperature increase. We are all going to fry to death. So with all this information, I thought maybe I can put together all this in creating a climate change model for 200 years. I started for 1900, go through today, and go to 2100. I focused on 4 parameters: CO2, temperature, population growth, world GDP per capita. When you plot all this, yes, it's all increasing. And I also put this bar here. This is the 2050. This is where the climate people, they want to put a stop to all this increase in CO2 and so on. This is where the net zero policy comes in. So their idea is to stop everything at this point. If you go beyond this point, you all will be fried to death when you reach this hot zone. Let's look at actually what is happening. Today's temperature is 14.51 degrees centigrade. If you use the IPCC value, that will increase 1.5 degree when you reach this point. So the temperature will be 16.01 degrees centigrade or 60 degrees Fahrenheit. You can actually verify or test this model. If the climate alarmists are correct, once you reach this temperature, you all will be fried to death. We can check today, right now. You can take your smartphone, check what is the temperature outside. I guarantee, whether you live in Athens, Ohio, or Princeton, New Jersey, it'll be higher than 60 degrees. That means you are living right now in this hot zone. You are not dead. You are not going to die today. So the climate change thing is just a hype. Everything will be normal. There will be normal population growth. There will be normal GDP growth. Everything will be fine. So what's the lesson from all this? The lesson is climate change is a natural phenomenon. It is not a crisis. It is not an existential threat to human beings. When you look at the entire geologic period, CO2 content is the lowest compared to the previous time period. We are here. During the past 570 million years, it goes up and down. Of course, during this plant evolution, it drops and so on, but we are here. So we don't have to worry about these things. Then one other point we learned is the Keeling curve. This is where they measure CO2 since 1958, and today it's 420 parts per million. Let's see where they are measuring. They are measuring Mauna Loa Observatory in Hawaii. This is the measuring area. This actually happened last November. It is a volcano. They blow up once in a while. When they blow up, they stop measuring CO2 because there is CO2 coming out of these fissures. Once the eruption stops, they continue the measurements. The problem is these fissures are open year-round. They're not light switches like you can turn it off, turn it on like that, and CO2 comes out all the time, whether there is eruption or not. Because what comes out is what is happening underneath in the magma. That determines what comes out. In fact, I would say this could be a year-round phenomenon. But the CO2 measuring instruments, they do not discriminate how much CO2 comes from the volcano, how much CO2 comes from fossil fuels. The idea of the Keeling curve is to determine the fossil fuel-induced CO2. If we really want to understand how much CO2 comes from the fossil fuel, we should measure these things in a city like Los Angeles, where there are a lot of cars, but there are no volcanoes. Okay, I would like to complete this talk with some good news. I'll start off with this slide. There has been some concerns regarding the rise in sea level. People are worried about the sea level rise is going to go so extreme, all the coastal cities will be drowned and so on and so forth. There is a recent study by Nichols and others published in 2021 in Nature Climate Change. And they looked at the data carefully, and they have concluded during the next 100 years, the rise in sea level is going to be 1 meter. So it's trivial. So we don't have to worry about this rise in sea level. What we have to worry about if you are swimming in the ocean, you should be worried about the shark underneath, not the rise in sea level. We already have cities like Amsterdam, New Orleans. They're all below sea level. They're managing perfectly well. So if there is a rise in sea level, we'll be able to handle them rather appropriately. The next, there is a concern that we are going to run out of fossil fuels in the next 10 years, 20 years, and so on. Nothing of that sort is true. British Petroleum has published data on the oil reserves, world oil reserves, and they have found since the 1980s to 2020, the oil reserve have been increasing and literally doubled. In addition, during the last year alone, we have discovered 10 major oil and gas fields all over the world. So during the next 100 years, there will be plenty of fossil fuels to use. That concern is not justified that we'll be running out of fossil fuels. Plus, we have fracking going on. With all that, there is no concern about running out of fossil fuels. The next good news is the global greening. There is a study recently published, and they have found the global area has underwent greening nearly 40%. The reason is the CO2. Because of CO2, the globe is getting greener. That's a good news. Finally, something about photosynthesis. We have sun's energy coming down radiation. Some of them get reflected. But photosynthesis has been going on because of the plants for a long time. Let's look at the origin of the formation of the Earth was about 4.6 billion years ago. And about 3.4 billion years ago, the first photosynthetic bacteria appeared. Then it goes on, and finally we have vascular plants. So there are two factors we have to keep in mind. the sun's radiation, the photosynthesis that influence the greenhouse gases in the atmosphere. So this has been going on for 3 billion years. And to think, since the Industrial Revolution that started 1760, 263 years ago, the human beings can overturn what has been done by nature, by sun and plants for over 3 billion years. It's just simply ridiculous, ludicrous. This is my concluding slide. Last, the item, roadmap for peace. Preserve the arts and heritage. Do not go out and destroy paintings like Mona Lisa, The Last Supper, and so on. They are our arts and heritage. It is easy to destroy them, but difficult to bring them back alive. Next, enrich life with fossil fuels. We have plenty of them. They are cheap, they are clean, and they're abundant. Appreciate the greening of the globe by CO2. CO2 is something we should cherish, something we should appreciate. So do not make CO2 be our enemy. Cancel the climate crusade or culture. Eliminate poverty with fossil fuels. The planet is doing fine. Just leave the planet alone. Focus on the people who need electricity and money and so on. So I would like to conclude this talk by thanking Patrick Jackson, who is the chair of the Ohio University Geological Sciences Alumni Board. He was the one who suggested this topic for today. And I would like to thank the chair, Dr. Lee, David Johnson, Travis, and Lisa. They are all very helpful. And Alex Epstein, who wrote the book on fossil future. He was kind enough to share many of the figures from his book, color figures, that I use today. And I want to thank Vaidiswaran and Geeta for their help with the computer problems. And I would like to thank Mobile Oil Company that gave me insight into what petroleum is and how important it is to human civilization. And I want to thank other organizations, particularly CO2 Coalition. They gave me color slides and so on. Finally, I want to thank the symposium participants who took 30 minutes of their time to listen to this talk. So thank you all very much. Thank you.